Alright, kind of a first video on the draft science section of Logerdome. I was going to make a real video where I actually did some draft science, but I'll just do some sort of overview kind of stuff in here, maybe something. I mean, just what's on my mind. I don't really have time to do I want to draw a picture of it, sort of, kind of thing. But yeah, I just want to set this page up, maybe have a comment section on this page. I'll try to set it up a little differently than the other pages and try to, maybe if it works, then migrate them into the same kind of forum. So anyway, just, thinking about physics, and so I will link to a hospital a day video that's really stale and boring, but it's sort of, and it doesn't say things directly, but it's sort of implying that, there is a lot of mathematics in physics, and a lot of that mathematics is based on formulas and that exploit relationships, but they might not be explicit relationships. They're convenient relationships. They exist, but they're not materially correct, functionally correct. They are, kind of a metaphor for the reality. I used a better word than that, and I'm not thinking of it at the moment. Abstraction. They're an abstraction, and there is a real mechanism. So it's like you could have a mathematical formula for playing Parcheesi, but it's going to be different than playing Parcheesi. It's just different than the real game. And it might be, well, there's no point in saying something like Parcheesi. Who the hell knows what that is? It's some stupid thing where you move marbles within triangles or something. But anyway, I'm just saying the math doesn't necessarily represent explicitly the reality. The math is solid. It's just limited. It's only half the truth, kind of a thing. It's not necessarily the whole truth. And so it can come up with some right answers, but they're not necessarily complete. It's not even a good way to put it. Especially when the formulas get very complex, then minor errors in each thing, like pi or something, could probably add up to a major error in calculation. But I guess a lot of it is based on this idea too that there's the trick to time messes up a lot of this stuff, and you use the word probability, and I don't, probability isn't really a reality. There is only inevitability, and probability has more to do with randomizing something, some variable, taking a variable and randomizing it, breaking it so catastrophically, making almost an infinite number of choices in one element of an equation to create the idea of a random result, because you've created a random variable. So like in rolling dice, the random variable would be the position of the dice in your hand when you throw them, and the angle that you throw them at, and the speed you throw them at. All these things would create variables that would randomize, because there's almost an infinite possibility, and especially in infinite combinations, seemingly infinite, that it creates random, because there's so limited a number of choices for the dice to come out as anyway. So anyway, but there's no such thing as probability. You're just saying, when you randomize it, what is its native possibilities? So it just, as soon as you randomize it, you just reduce it to its native possibilities. Yeah, possibilities are different than probability. Anyway, but yeah, there's no such thing really. Like I said, it's always inevitable what's going to happen in any one instant. And so the argument sort of being made here, okay, I think hostile day is implying anyway, and I'll say it more directly, is that there's a real physics happening. Okay, there's no such thing as non-material events, non-caused events, non-caused effects. Effects are always caused by a circumstance, and the circumstance has a character. And so there isn't photons bouncing all over the place and all that kind of crap, and they don't appear here and disappear there and do all this magic stuff. It's all very explicit in the reality. And it's just that it's an unseen reality, so therefore we only see a result that is so distant from the actual mechanics. It's just, there's a lot more complexity. We're just seeing this crude outcome that doesn't have anything to do with what made the outcome possible. And there's a whole complex chain of events that did that. Anyway, character of the circumstance. So he also had grid work, as a part of his example, and I like the idea of this grid thing, that the quanta can be broken down, and you could have just a very simple rules, left, right, forward, back, up, down, where something can move on, on a Planck constant of time, and that the whole universe is made up out of that. And so, like, when something, I've said this before, but I like this idea, when something moves, the bits inside of it are all moving at the speed of light. Nothing moves in the universe except at the speed of light. There is nothing going slower than the speed of light. Even though it looks like it's going slower, the stuff inside of it isn't going any slower than the speed of light. So all the little bits are actually moving. And for something to move from here to there just means that more stuff had to move the speed of light in this direction than moved in any other direction. So that the end result was getting everything to go this way, was merely aligning everything specifically to make that be the result. So it's all about alignment and direction. So all you're doing is changing the direction of matter when you change its speed. So when a piece of matter changes its position, you change the direction of the photons, or the quanta inside of it. You changed how they moved, not how this moved. And that thing only moves because you change those directions. But you don't migrate anything in terms of moving something that's still moving its regular way. You change its regular way to change how the matter itself moves. You end up changing the energy inside the matter, and that'll change how the matter moves. Yeah, I think that's an adequate description. So anyway, going further, sorry, I'm just fixing this. I'm trying to fix this. There. So anyway, so I was thinking about the bonding between atoms, and atoms can they can survive without electrons, but electrons are basically what glue this stuff together. So if you want two things to stick together, you need these electrons to tie them together, and tying is kind of a key concept. So I was thinking of electrons as being photons, but just in a lot of photons, a long string of photons, and that long string is basically what's ending up holding the atoms together, because the string is flowing between the two electrons, and so you have to actually break the electron to break the bond that's been created. And that's what's bonding, is the electrons, and the connections are really the connections between the quanta inside the electron is what you're breaking. And the catch is that there has to be a difference in the way electrons are structured, where they don't quite go the speed of light. So there has to be, I was thinking, well, obviously you can do just that spring thing where they spin. So if they spin a little bit as they move, like a spring, they have a little twist in there, off-center, a little bit off-center in how they get from one place to another. That could slow them down just a little bit, depending on how wide or compressed that spring was. So the more compressed the spring is, the more spinning they do, and the less forward movement they make. And the more spread out the spring is, the less waste in direction or movement is wasted in spinning, and so they move faster. The line is made straighter. So as you pull the spring wider, you shorten the distance, and therefore the shorter distance equals less time. So anyway, yeah, I like that. That's another concept I'm kind of comfortable with. But yeah, so I think everything's made out of this quanta stuff, this little bit that just does this simple movement, and then they just tie to each other. So it's just figuring out how they tie to each other and how they form shapes, because there's a certain shape that's involved in all of this stuff. Light has a shape. It's how it can be polarized. And electrons clearly have some sort of function or shape that slows them down a little bit. Keeps them below the speed of light. Yeah, so that's probably enough. But it's a schooling of quanta that forms the more massive particles that we are able to detect when we split atoms. We basically can only detect things that are a certain size. They have to be a certain size for us to be able to detect them. And there is obviously a limitation to what we can possibly detect in terms of something having enough of a substance, enough of an impact on the matter around it for us to be able to detect it. So theoretically, there could be a lot of matter in the universe, in the form of energy, that we can't detect simply because the energy is too small. It's too few quanta for us to have any instrument that could realize a change in its function because of an impact with that. I mean, the only way we can really detect something is to impact it, to interfere with it. And it has to create some sort of change in the thing it hits for us to see the change in what it hit. So anyway, I'll work on it. So this video is just a way of setting up the page anyway. And I will do more, write more, just kind of put down these basic statements about what I think is happening, and then try to take that simple starting point and see if I can get to the complex reality from that simple diagram. That's sort of the plan, is to see if I can build a Frankenstein out of these simple parts. So, until next time.